Hello students, I am going to make some video lectures for the unit 6, which is comprising of a topic called Semiconductor Electronics, Materials, Devices and Simple Circuits. This video lecture will be consisting of 4 modules, and each modules are divided like this. Module number 1 is consisting of materials, semiconducting materials. Here we will discuss about the semiconducting materials, the conductors, insulators, semiconductors, all these things. Specifically, we will start with band theory of solids, where we will discuss how during the process of crystallization, means how when the atoms of a crystal comes together, the energy levels of the valence electrons get modified. That means when the atoms of a crystal comes together to form the crystal, the energy levels of the valence electron get modified to form a band, energy band. And that theory behind that, procedure behind that, and all aspects, physical aspects behind them, we'll discuss in band theory of solids. After that, we'll classify the solid into conductors, insulators and semiconductors based on this band theory of solid, as well as based on the values of conductivity and resistivity. After classifying the solids into conductors, insulator and semiconductor, we will leave the conductors and insulator apart and will focus on this story on semiconductors. What are semiconductors? What are the typical values of conductivity and resistivity of a semiconductor? How they behave? Why they are called semiconductors? All these things we will discuss. And we will classify again the semiconductor into two types. One is called intrinsic semiconductor, another is called extrinsic semiconductor, where intrinsic semiconductor is also called as pure semiconductor and extrinsic semiconductor is also called as impure semiconductor. We will discuss why they are called pure and impure semiconductor, what is the logic behind calling like that intrinsic and extrinsic semiconductor. All these things we will discuss in this part. After finishing this, again we will divide the extrinsic semiconductor, which is more important from the device application point of view. We will divide the extrinsic semiconductor into again two types. One is called p-type semiconductor and one is called n-type semiconductor. How you can get p-type semiconductor, how you can get n-type semiconductor, what are the majority and minority charge carriers in p-type semiconductor and n-type semiconductor, what is the process of conduction in p-type and n-type semiconductors. Those things we will discuss in this part. And after that we will finish this module 1, which is basically discussing the materials, semiconducting materials, their types, their behaviors, all these things we will discuss in this first module. In second module, by using the p-type and n-type semiconductor, we will form a p-n junction diode. Okay, in specifically we will see how the p-n junction diode can be formed, and when a p-n junction diode can be formed, a depletion layer will come into exist. How the depletion layer is forming and what is the logic behind forming of that depletion layer, what is the physics behind forming of this depletion layer, that we will discuss in the second module, first part of the second module. After that, we will see what will happen if we will supply a biasing voltage to a semiconductor diode, how the diode will behave, and that behavior of diode when you are supplying a potential across the diode, that is called biasing potential. That behavior is called diode characteristics. We will discuss the diode characteristics also. What is their behavior in the case when you are supplying a potential across the semiconductor diode. Afterwards, we'll discuss how these characteristics of a diode, p-n junction diode, can be used as a device, can be used in the form of as a device application For example, how this PN junction diode characteristics can be used in the process of rectification and in the process of rectifying full wave and half wave both, and accordingly we will discuss along with simple circuits. We will discuss how a half wave rectifier and how a full wave rectifier works. So we'll with simple circuits we'll discuss the PN junction diode as half wave rectifier as well as full wave rectifier. Afterwards, we'll discuss a special PN junction diode that's called a Zener diode. Its behavior is little different than the simple PN junction diode, and how the behavior of a Zener diode or characteristics of a Zener diode can be used to realize a voltage regulator. Okay, by using a simple circuit that we'll discuss in module 2. So basically in module 2 we'll discuss the formation of a PN junction diode and the characteristics, potential and current characteristics of a PN junction diode, and some simple device applications of a PN junction diode like half wave rectifier, full wave rectifier and voltage regulator. This will summarize the second module 2. After finishing module 2, we will move to module 3, where we will discuss bipolar junction transistor and simple circuits using bipolar junction transistor. Specifically, we will first discuss how a bipolar junction transistor can be formed, like how a PNP bipolar junction transistor and how a NPN bipolar junction transistor can be formed from the P-type and N-type extrinsic semiconductor material. After discussing that, we'll discuss what are the different configuration in which a bipolar junction transistor can be biased, can be given potential. All those configuration like common base, common collector, common emitter configuration we'll discuss, and what are the use of these kind of different configuration, those also we'll discuss. Why we are giving some certain configuration to this bipolar junction transistor, those things we will discuss in third module. Okay, after finishing that, we'll discuss how to bias a transistor, bipolar junction transistor, and what are the different characteristics in different configuration. In common base configuration, how to bias a transistor and what are the characteristics, both input and output characteristics. In common emitter configuration, how to bias a transistor and what are the different transistor characteristics, both input and output characteristics. Those things we'll discuss in this part. After finishing that, we'll try to see how a bipolar junction transistor can be used in some device applications. For example, how a BJT or bipolar junction transistor can be used as an amplifier, and how a bipolar junction transistor can be used as a switch. Those things we'll discuss in this module, and this will summarize the entire module. Module number 3. After finishing module number 3, we'll go to module number 4, where we'll discuss about digital electronics. Here basically we'll start introducing with the difference between digital electronics and analog electronics, and how the Boolean algebra helps us in discussing or in implementing the digital electronics. Those things we will discuss in the first part of this module. Afterwards, we'll introduce logic gates, and we'll analyze how AND, OR and NOT logic operations can happen using some simple circuits. What are the electronic circuits which can give you these logic operations in reality? Okay, AND logic, OR logic, NOT logic, and how electronically we can achieve these logics, and those are called logic gates. Those things we will discuss in this part. Afterwards, we will discuss NOR gate and NAND gate. Okay, and how this NOR and NAND operations can be achieved by using simple electronic circuits. Those things we will also discuss in this part. And after that, we will try to justify that how this NAND gate and NOR gate can be called as a universal gate by achieving or by realizing all these AND gate, OR gate and NOT gate. By using NAND gate and NOR gate, we can justify that NAND gate and as well as NOR gate are called as universal gates, since all other logic operation, all other logic gates can be achieved, can be realized using NAND and NOR gate. So this will finish our entire unit 6 or entire video course, and it's not necessary that every module can be finished within one video lecture. Each module can be consisting of 4 or 5 video lectures or 6 video lectures, depending upon the content, and wherever the content is more, the number of video lectures will be more, and wherever the content will be less, number of video lectures will be less. But one thing is definite, that all video lectures will be of maximum duration of 35 to 40 minutes, not more than that. So accordingly, all these modules will cover step by step, one by one. Each module will be consisting of few video lectures, 5 to 6 video lectures. Okay. So this is the outline of the entire unit 6 video course that I am going to present to you. Now, one of the most important point in case of any course curriculum, any course material, designing any course material, is the course outcome. Means after finishing the course, after looking at the video lectures, what course outcome you will get. Knowing those course outcome prior to starting the video lecture is very much important, in a way that if you know the questions, or if you know the outcome, if you know the things which you will be able to answer after learning this, then you will get enhanced interest to learn about this course material, about this course. So it's always better to discuss the course outcome at the initial itself, at the starting itself, so that students will get more interest to learn about the course. We'll discuss course outcome for each individual module. In module number 1, after learning this module, you will be able to answer following questions. How various energy bands form during the process of crystallization. When you are forming a crystal by bringing various atoms close together, how the energy bands are forming, because initially when the atoms are isolated, when they are not in the form of a crystal, the energy levels are very much distinct. So, but when you are bringing them together, the energy levels, the valence electron will interact with each other, and the energy level will be modified, and they will form a band. How those bands are forming, okay, that you will be able to answer after learning this course. And how these energy bands play a role in classification of solid into various types. How by depending upon the energy levels or energy bands, by seeing the energy bands, how can we classify the solids in various type of solids like conductors, insulators, and semiconductors, by seeing the energy band. That you will be able to answer after learning this course. Afterwards, what are the conductors, insulators, and semiconductor and their typical properties? Typical properties means what are their conductivity, what are their resistivity, what are the energy gap between them. Those things you will be able to answer by after learning this course. And you will be able to answer what is intrinsic semiconductor, what is extrinsic semiconductor, what are p-type semiconductor, what are n-type semiconductors. All these things you will be able to answer, and what are the differences between these kind also you will be able to make. You will be able to make the difference between intrinsic and extrinsic semiconductor. You will be able to make the difference between p-type and n-type semiconductor after learning this course. And what are majority charge carriers, what are minority charge carriers, and how the majority and minority charge carriers depend upon the temperature as well as depend upon the doping concentration. All these things you will be able to answer after learning this module. Okay, and what are the effects of temperature and doping on the conductivity of the semiconductor? Also, you will be able to answer after learning this course material, this particular. Following. That means by learning this module, you'll be able to answer following questions. How a p-n junction formed resulting a depletion layer. That means when you are mixing one p type and when you are joining one p type and one n type semiconductor, a p-n junction is forming. How there is forming, and because you cannot join them directly, there is a certain procedure, certain rule to join them. Okay, and how that p-n junction is formed, and once a p-n junction is forming, how the depletion layer is coming into play, that you will be able to answer after learning this module number 2. After that, what are forward and reverse biasing of a p-n junction? How you can bias a p-n junction in forward way or in reverse way, that you will be able to answer. And what are the effect of this forward and reverse biasing on p-n junction diode? That means this diode characteristics you will be able to answer. When you are biasing a p-n junction in forward way, what are the effects? When we are biasing a p-n junction in reverse way, what are the effects? Those things you will be able to answer after learning this particular module number 2. And what are the characteristics of a p-n junction diode in forward bias and reverse bias? You will be able to answer. Also, you will be able to answer how a p-n junction can be used as rectifier, how a p-n junction diode can be used both as half wave rectifier as well as full wave rectifier. You will be able to answer. You will be able to draw their circuit diagrams, electronic circuit diagrams. You will be able to discuss how process is happening, how rectification is happening. All these things you will be able to answer once you will learn this model. And at the end, you will be able to answer also what is a Zener diode, what are the characteristics of a Zener diode and how it works, and how a Zener diode can be used as a voltage regulator. That also you will be able to answer if you learn this particular module. After that, the outcomes of module number 3 are as below, as following. That means after studying the module, you will be able to answer these following questions. What is a bipolar junction transistor and how it is formed? How to make a bipolar junction transistor, that you will be able to answer. And after that, you will be able to answer how a both PNP and NPN bipolar junction transistor works when you are supplying a potential, when you are biasing the bipolar junction transistor in various configuration, how they are working, that you will be able to answer. Also, what are the various biasing configuration? Common emitter, common base, common collector. What are the different biasing configuration a bipolar junction transistor can be biased? That you will be able to answer after learning this module. And what are the input and output characteristics of a BJT in all these configuration? That you will be able to answer. Input output characteristics means when you are biasing a bipolar junction transistor in certain configuration, how the input port is behaving and how the output port is behaving, that those are called input and output characteristics, and you will be able to answer those things if you study this module number 3. And how a BJT can be used as amplifier for device application point of view, how a BJT can be used as an amplifier as well as how a BJT can be used as a switch, you will be able to answer along with their circuit diagrams. Along with the simple circuit, electronic circuit diagram, you will be able to answer, you will be able to discuss the application of BJT as amplifier as well as switch. These are the outcomes of module number 3. Now, the outcomes of module number 4 are as below. After studying this module, you will be able to answer the following questions. What is the difference between digital and analog electronics? How to distinguish between digital and analog electronics? And what are the logic operation and Boolean algebra? How Boolean algebra helps us in implementing the digital electronics, or in realizing the digital electronics, how Boolean algebra helps us. That's also you will be able to learn by this module. And you will be able to answer what are the various logic operations along with the truth tables like AND operation, OR operation, NOT operation, along with their truth tables and along with their electronic circuits. You will be able to answer how these logic operations are happening or working. Also, you will be able to answer what are NAND gate, NOR gates, and why they are treated as universal gate. that also you will be able to answer along with proof. Like NAND gate and NOR gate, they are treated as an universal gate because all other gates can be realized using these two gates. So you can realize all other gates. You will be able to, or you will be learning to realize all other logic gates by using both NAND gate and NOR gate. So that will be a justification why NAND gate and NOR gates are called universal gate. Now before going to discuss these modules in details, it's advisable to have a brief introductory knowledge about what electronics is. Now, what is electronics? Electronics comprises the physics, engineering, technology and applications that deal with the emission, flow and control of flow of electrons in vacuum or matter. So electronics, let me repeat, electronics comprises the physics, engineering, technology and applications that deal with the emission, flow and flow control of electrons in vacuum and matter. That means how the physics of how electrons are getting emitted, the engineering of how to control the flow of electrons and generation of electrons, the technology of how to use this flow control and generation for some device applications is nothing but the electronics. Now in initial days, the flow control and generation of electrons were realized by a device or by some devices which are called vacuum tubes. These vacuum tubes are basically some glass tubes made up of completely vacuum. The glass tubes which are made completely vacuum and are consisting of several electrodes. Some one electrode, some vacuum tubes were consisting of 2 electrodes, some vacuum tubes were consisting of 3 electrodes, some vacuum tubes were consisting of 4 electrodes and so on. Now depending upon the number of electrodes in the tube, they were called as either diode. If it is having 2 electrodes, it is called diode. If it is having 3 electrodes, it is called a triode. If it is having 4 electrodes, it's called a tetrode and pentrode and so on. Now basically in a vacuum tube, the two important electrodes which must be there were called as cathode and anode. The cathode was responsible for generating of electrons and the anode was responsible for receiving those electrons generated by the cathode. And the whole arrangement is called a vacuum valve or vacuum tube. And in some electrodes, some vacuum tube, another or extra or 2 extra electrodes will be there. Those are called as valve, and these valves are responsible for controlling the flow of electrons from cathode to anode. So if it is a triode, then there will be one cathode, one anode and one valve. Cathode is responsible for generating electrons, anode is responsible for receiving electrons, and valve is responsible for controlling the electrons. If it is a tetrode, then there will be one cathode, one anode and 2 valves, and both the valves are responsible for controlling the flow of electron. So these were the devices which were being used initially in earlier days. But these devices were having some disadvantages, some shortcomings. What are those disadvantages? These are very bulky. Bulky means, I'll give an example. In initial days, one small computer was having a size of a 10 by 10 room. The computer was consisting of so many number of these kind of valves or tubes which are very bulky, which eventually made that computer to be very bulky, of the size of a 10 by 10 room. Second disadvantage is these operates at very high voltage, nearly 100 volts. If they are operating at nearly 100 volts, very high voltage, then the power requirement will be very high, power consumption will be very high, and hence they are not power efficient. Another disadvantage is their limited lifetime. The lifetime of this vacuum tube are very less. That means somehow if the vacuum is leaked, if the tube got leaked somehow, then this tube got damaged and it will not work further. So their lifetime is very less. In a similar way, the electric bulbs we are using in our daily life, everyday life, those were also kind of vacuum tubes. Similar to them, the lifetime of these vacuum tubes were very less, limited lifetime. Another disadvantage was low reliability. These vacuum tubes, you cannot trust these vacuum tubes to a high extent. I mean, these vacuum tubes can go bad eventually, suddenly, without giving any prior notification, or you are giving any prior indication. So you cannot trust them to a large extent. So their reliability is very low. Later on, researchers found that some solid-state semiconductor materials and their junctions offer the possibility of controlling the number of electrons and the direction of flow of electrons through them. And this possibility and this facility which some semiconductor materials or some solid-state materials were offering, these leads to the realization of semiconductor electronic devices. What is electronic devices? Electronic devices are those in which we can generate and control the flow of electron and can receive those electrons. And some electronic material and their junctions offers the possibility of generating, controlling and receiving those electrons. Hence, later on, people try to realize semiconductor devices, these electronic devices from semiconductor materials. Okay, some examples are diode. This is a diode, and triode transistors, bipolar junction transistors, or field effect transistors. Lot of kind of transistors are there. Light emitting diode and all. And these semiconductor materials, semiconductor devices, electronic devices, were having some advantages over those vacuum tubes. What are those advantages? They are very small in size. I mean, they are very minute. And as an example, nowadays one computer, you can hold a computer over your lap or over your tabletop. Okay, so such a small size now computer has become because of the teeny size of these electronic devices. And their operating voltage is also very low, few volt, few millivolt, in few millivolt or few volt they operate, and hence their power consumption will be very less. So they consume very small power, and they have long lifetime. These diodes and transistors, they don't go bad very easily. Their lifetime is very high, means years and years, like 3 years, 5 years, they can survive without getting damaged. So they have long lifetime. This is also an advantage over the vacuum tube. And they have high reliability. You can trust, you can believe the semiconductor devices, electronic devices, which are these electronic devices which are made up of semiconducting material. One very nice example of the small small size of the tiny size of semiconductor devices, the semiconductor electronic devices are these. Earlier, the television sets which are working in the technology of vacuum tube, which are having this cathode ray tube, CRT monitor. They are called CRT monitor tubes. In initial days, we are having CRT monitor televisions. They were working on the principle of this vacuum tube, and they were obviously very bulky because of that. Nowadays, when this liquid crystal display technology came into picture, look at the television sets at your houses. Those television sets, these television sets which are using now liquid crystal displays are very compact in size, just because of this tiny size or small size of semiconductor devices. Okay, so these are the advantages of semiconductor devices, and since this vacuum tube technology now nowadays these vacuum tube technologies are not in in place. People are not using vacuum tubes for realizing the device applications. Hence, we are not going to study in detail about them. We'll be concentrating on semiconducting material and some devices which can be prepared, which can be realized from the semiconductor materials and their simple circuits. Those things we'll be concentrating on from now onward, without going in detail to this vacuum tube technologies. So from next class onward, next video lecture onward, we'll go in detail to study about those modules, and at first we'll be starting with module 1, which is consisting of, or which is going to discuss about materials, semiconducting materials. Thank you.